Unlike stannous chloride, which is a solid, stannic chloride is a liquid. Why? Because stannic chloride, the polarity has gone from class 2 to class 4. So charge to size ratio has increased, covalency has increased. As a result, it changes from solid to liquid. So stannic chloride, because of higher charge to size ratio, the covalency has increased and has converted into a liquid. Why it is a fuming? Fuming because stannic chloride will, in presence of water, will form, it will hydrolyze and liberate HCl gas. And that HCl gas forms a fumes. So in presence of moisture, stannic chloride will appear as a fuming liquid due to the liberation of HCl as a result of hydrolysis of stannic chloride.
So what enables a mordant to be act as a fixing agent for the dyes? So how does a mordant work as a fixing agent for the dye?
Because there is an interaction between mordant and the fabric and the mordant and the dye. There is some interaction. That is why it acts as an intermediate. So the cellulose, there is an interaction between cellulose and the mordant, and that mordant helps the dye onto the cloth. Stannic chloride can also be prepared if you distill tin with excess of mercury chloride. When I use tin and mercury chloride 1:1, I got stannous chloride and mercury. When I take excess of mercury chloride, I get stannic chloride and mercury. Stannic chloride, when you react with HCl, it forms H2SnCl6, which shows stannous chloride is a Lewis acid.
Yes.
Because the chloride is a Lewis base. So which accepts Lewis base is an acid? So stannic chloride accepts chloride ion, which is a Lewis base. So stannic chloride behaves as a Lewis acid. Stannic chloride, when I react with 2 moles of ammonium chloride, I get NH4 2SnCl6, which is known as pink salt. This is used as a mordant for pink dyes. So for pink dyes, the calico printing requires pink salt as a mordant. Then we go to the next element, the lead. That's all about chemistry of tin, okay? If you have any question, do you have any question about tin?
Sir, that alpha between that which beta tin and means the stainless steel. Can
Why
we
does
compare
it
that?
change? Why does it change to alpha tin?
No. Means between the comparison, if you compare the beta tin with our stainless steel, then which is a good substance?
Stainless steel.
Sir, in the preparation of the purple of Caceres, sir, we had oxidized essence.
Purple of Cassius.
Yes.
Ah.
Sir, we had oxidized SnCl2 to SnCl4 and then hydrolyzed to stannic acid.
Yeah.
Sir, after that we had done the reaction of SnCl4 with water, 2 moles of water, where we had got SnO2 with HCl. So what is the difference between these two reactions? Both are done with water.
SNO2 is the ultimate product. H2SNO3, tin dioxide is ultimate product. It is a it requires 2 moles of water to give you tin dioxide plus 4HCl.
4HCl.
What is stellic acid? Tin dioxide with 1 mole of water.
Yes.
So it is a hydrated tin dioxide is tannic acid. That's all.
Yes, sir. Yes.
Both are the hydrolyzed product of tannic chloride. Okay?
Yes.
When I dissolve tin in dilute nitric acid, I get tin dioxide. When I dissolve tin stannic chloride in water, I get, or stannous chloride, when I add to gold chloride, I get stannic acid. Because stannic chloride undergoes hydrolysis to give stannic acid. Stannic acid is nothing but tin dioxide plus 1 mole of water. That is the
Yes.
hydrated form of tin dioxide is stannic acid.
Sir, in this reaction as mentioned of SnCl4 with H2O, why doesn't a portion of SnCl4 combine with H2O to form butter of tin? Why does it form SnO2 and 4HCl?
Stannic chloride, I said, forms a variety of hydrates. One of the hydrate is known as butter of tin, which has a composition 1 mole of stannic chloride with 5 moles of water. That is known as butter of tin. It is very soft substance, and that is why it's called butter of tin. It acts as a mordant. It doesn't mean that the stannic chloride does not form other hydrates. Only particular this hydrate is known as butter of tin, which is used as a mordant.
So when unhydrated substance, if it is reacting with water, then how come at the same time it is also forming a hydrate with water of crystallization?
In presence of acid. In presence of acid. If you crystallize from acidic solution, dilute acid solution, the water concentration is much higher. What is the water concentration? 55.5 moles per liter. Whereas if you add acid, 0.1 molar, it is nothing. So when you crystallize from acidified solution, you get this variety, where it does not hydrolyze because of the presence of the acid, but you have a overwhelming concentration of water molecules, a large number of water molecules. So there is a possibility of getting hydrated. And one of the hydrate is known as stannic chloride pentahydrate, is known as butter of tin. The sources of lead or the minerals of lead are lead sulfide, that is galena, lead carbonate, that is called cellucite, lead sulfate is called anthracite, and lead monoxide, lead sulfate is called lanarkite. 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 The principal ore of lead is lead sulfide. Lead sulfide on heating gives you lead monoxide plus lead sulfate, and lead monoxide plus lead sulfide gives you lead plus sulfur dioxide. That is one reaction. The second reaction is lead sulfide plus lead sulfate gives you lead and 2 moles of sulfur dioxide. And these reactions are called self-reduction reactions. Just like copper sulfide plus copper oxide give you copper and sulfur dioxide, lead sulfide and lead monoxide gives you lead and sulfur dioxide. Lead sulfide and lead sulfate gives you lead and sulfur dioxide. So the lead which you get from galena by self-reduction method is further purified by electrolytic method, where you take impure lead as anode, pure lead as cathode, and lead silicofluoride and hexafluorosilicic acid as electrolyte.
Excuse me, sir. Sir, is there any significant reason for adding hexafluorosilicic acid?
Yes, to prevent the hydrolysis. To prevent the hydrolysis of lead ion. There are 2 varieties of lead monoxide. When you heat lead with oxygen at 300 degrees Celsius, you get a yellow powder which is known as massic powder. Then when you heat it to a higher temperature in absence of oxygen, the yellow powder changes to a reddish-orange crystal of lead monoxide. The chemical composition does not change. That is, just powder changes to crystalline form at a higher temperature, and that is called litharge. So if lead monoxide, if you heat it to 470 degrees Celsius, the yellow powder changes to scarlet red color, a deep red color. As soon as you see this word, close your eyes and write, that is called red lead, which is red in color. So 3 moles of PbO, when you heat in presence of oxygen, the yellow converts into scarlet color, red, a deep red, and this is called red lead. Red lead is a mixed oxide. It contains 2 moles of PbO and 1 mole of PbO2. If you add up, you will get Pb3O4. Check yourself. Since it contains lead dioxide, so any reaction which red lead will give, lead dioxide will give, red lead will give the same reaction, because red lead contains lead dioxide. PbO2, lead shows 2 oxidation states, +2 and +2. And +2 is the most stable oxidation state due to inert pair effect.
Yes.
PbO2, how can I prepare PbO2? PbO2 is insoluble in water and in dilute acids and is brown in color. Remember that lead dioxide is insoluble in dilute acids and water and is a brown color. Okay?
Yes.
What is the oxidation state of lead in lead dioxide?
+4.
So it will show an oxidizing behavior. Okay? Yes. So if I react lead monoxide and lead dioxide, a mixed oxide is red lead.
Yes.
When I add dilute acid, this is not insoluble in dilute acid,
Yes.
so it precipitates. Lead monoxide dissolves in nitric acid to form lead nitrate and water. So I get a colorless solution. The supernatant liquid will be colorless. That is made of lead nitrate. And at the bottom I will get a brown precipitate, which is lead dioxide. Second method, if I take lead monoxide and react with HCl, I get lead chloride. Or if I take lead nitrate and add HCl or sodium chloride, I get a white precipitate of lead chloride. Lead chloride is soluble in hot water. This is a property of lead chloride, that if I take lead nitrate and add HCl or sodium chloride, it will convert lead nitrate to lead chloride. It is insoluble in cold water, but if I warm it, the precipitate will dissolve in hot water. When I cool it, again the precipitate will come back. And that is a test for lead chloride. Lead chloride and sodium hydroxide will give me lead hydroxide and sodium chloride. Sodium hypochlorite, you treat it as sodium chloride plus nascent oxygen. Hypochlorites are strong oxidizing agents because they evolve nascent oxygen very readily. Nascent oxygen oxidizes lead 2 to lead 4 plus and converts into lead dioxide. So 2 plus to 4 plus, the nascent oxygen oxidizing lead 2 plus to 4 plus, getting reduced to oxide R. So you have PbOH2 and oxide ion. Remove a molecule of water, you get lead dioxide. You have PbOH twice dot O. If you remove a molecule of water, what is left behind? So lead 2 plus is oxidized by nascent oxygen to lead 4 plus, and oxygen gets reduced to oxide ion. And in this way, you get lead dioxide as a brown precipitate, and sodium chloride is soluble in water. So it remains in the aqueous solution, and the precipitate of lead dioxide is formed. You filter off and wash with water, you get lead dioxide. The third method is so now I start with lead hydroxide and treat it with bleaching powder. The bleaching powder goes to calcium chloride plus nascent oxygen. And this nascent oxygen oxidizes just like the earlier reactions. Nascent oxidized oxygen oxidizes lead 2 to lead 4 and gets reduced to oxide ion. Remove a molecule of water, you get lead dioxide. Calcium chloride is water soluble, whereas lead dioxide is water insoluble, so you get a brown precipitate. So second and third method are the same method, concept-wise same. In one case, I start with a chloride salt, convert into hydroxide, and then react with hypochlorite to get lead dioxide. The third method, I start with lead hydroxide and react with bleaching powder and another oxidizing agent. Why bleaching powder is an oxidizing agent? Because it gives nascent oxygen. Lead dioxide, remember this reaction very carefully, that lead monoxide on heating, lead dioxide on heating will give lead monoxide and oxygen. Don't forget this reaction because this is a very important reaction of lead dioxide. So lead dioxide, when you heat it with concentrated nitric acid, what you look at? You will get lead dioxide will change to lead monoxide and oxygen? Yes. Okay? Yes. You will not get nitrogen dioxide, no brown fumes. You will get lead nitrate, oxygen and water. If you take copper with concentrated nitric acid, you will get copper nitrate, nitrogen dioxide plus water. Yes. But lead will not give you nitrogen dioxide. Lead will not give you sulfur dioxide when you heat it with concentrated sulfuric acid. It will always give you oxygen. And lead monoxide dissolves in nitric acid to form lead nitrate. So I will get lead nitrate, oxygen and water. Similarly, lead dioxide with concentrated sulfuric acid will give me lead sulfate, oxygen plus water. No sulfur dioxide. Remember, this is a very special type of reaction. Not many metals show this type of reaction. Lead nitrate. We'll discuss lead nitrate little later. Just write down lead nitrate so that I remember I have to discuss. Okay. Lead dioxide plus concentrated HCl under cold condition. I will get lead chloride plus water. When I am not heating, I get lead tetrachloride. As soon as I heat it, I get lead chloride plus chlorine. As soon as you heat, lead 4 plus is an oxidizing agent, so it oxidizes chloride to chlorine and get reduced to lead 2 plus.
Yes.
Balance this reaction. You can see that lead is such a powerful oxidizing agent. What is the oxidation state of manganese? What is the oxidation state of manganese here? So it is oxidizing plus 2 to plus 7. So you can imagine how strong an oxidizing agent lead dioxide is. It oxidizes manganese 2 to manganese plus 7. So it's a 5 electron change. For lead, it is a 2 electron change. Lead 4 plus going to lead 2 plus. Manganese 2 plus going to manganese 7 plus. So it releases 5 electrons.
Yes.
And it, lead 4 plus to lead 2 plus, it accepts 2 electrons. Make the electron count same. Then what do I do? Cross multiply? So 5 moles of lead dioxide will react with 2 moles of manganese nitrate. Now, 2 manganese already there in this lead permanganate, which is purple color. So already both the manganese is in the form of permanganate. But I have 5 lead. So there will be 4 lead nitrates. Okay?
Yes.
Now, manganese nitrate gives me how many nitrate? 4. 4 lead nitrate requires 8 nitrate ion. So 4 nitric acid. That means 2 moles of water. Do you understand? So this is how you have to do the balancing of equations. That make the electron count same. So that in order to make the electron count same, you have to just cross multiply. Lead undergoes 2 electron change, manganese undergoes 7 electron change. So I require 2 moles of manganese, 5 moles of lead. 1 mole of lead includes both the manganese. So the remaining 4 moles of lead will convert into lead nitrate. Lead nitrate. I have told you how to prepare lead monoxide by heating lead in oxygen. At 300 degree it gives lead monoxide massicot. At 900 degree it converts into lethal. There is another method to prepare. There are other 2 methods to prepare lead monoxide. One is lead nitrate on heating gives lead monoxide, nitrogen dioxide plus oxygen. Another is lead carbonate on heating gives lead monoxide and carbon dioxide. So these are the 3 methods by which you can prepare lead monoxide. Normally, heavy metal nitrate, like copper nitrate, barium nitrate, lead nitrate, they give on heating nitrogen dioxide and oxygen and the metal oxide. But sodium nitrate on heating gives sodium nitrite and oxygen. Potassium nitrate on heating, potassium nitrite and oxygen. Okay? But now put a star mark. Lithium nitrate on heating, lithium oxide, nitrogen dioxide plus oxygen. See that how lithium differs from sodium and potassium.
Yes.
Lithium is the lightest metal, but it behaves like a heavy metal as far as the nitrate decomposition is concerned. Heavy metal nitrate gives nitrogen dioxide and oxygen. Lithium nitrate gives like nitrogen dioxide and oxygen, despite the fact that lithium is the lightest metal. So this is an anomalous behavior of lithium. There is one compound called sugar of lead. Lead acetate is called sugar of lead. And lead acetate on heating. Lead acetate on heating gives lead monoxide, acetone, and carbon dioxide. So lead acetate, this is put a star mark. That lead acetate on heating gives lead monoxide, acetone and carbon dioxide. Now there is another compound which is called white lead. This is used as a white paint. It is 2 moles of lead carbonate with 1 mole of lead hydroxide and 2 moles of water. This is called white lead. This can be prepared from lead nitrate on reaction with sodium carbonate plus water gives you. So how many moles of lead nitrate I require? How many lead atoms are there? 2 plus 1, 3? So I need 3 moles of lead nitrate. How many carbonates are there? 2 plus 1 carbon dioxide. So I need 3 sodium carbonate. That takes care of 3 carbon, 2 carbon here and 1 carbon here.
Yes. 6 and 8.
I will have 6 moles of sodium nitrate.
Yes.
And the oxide ion, carbonate ion, is nothing but carbon dioxide plus oxide ion.
Yes.
So carbon dioxide is already there. So the oxide ion reacts with water to give you 2 hydroxide ion, and that is there.
Yes.
And this is called a Carter's process. So this is how you have to do research with yourself. Book will not write this, okay? Book will write simple this plus this gives this. But how does it occur? That you have to think yourself. That's why hydroxide ion is formed. Because the carbonate ion has 3 oxide ion. And in carbon dioxide I am using 2 oxide ion. So what happens with the extra oxide ion? That reacts with water to give 2 hydroxide ion, which combines with lead to form lead hydroxide. Is it clear?
Yes.
Okay. Now, this is a white paint, but it suffers from a disadvantage that in presence of H2S in the air, this converts into lead sulfide, which is black. So the white lead, the white paint turns into black because of the presence of H2S in the environment. So due to presence of H2S in air, it will slowly change into black color. But if I react with hydrogen peroxide, I can get back white color. But I don't get back white lead, I get lead sulfate. Lead sulfate is white, so the color becomes white. Not due to formation of white lead, due to formation of lead sulfate. When you heat it, it gives you red lead. So white lead on heating gives you, the white color changes to red color. So you get red lead, carbon dioxide, water. So the white color changes to red color with the evolution of carbon dioxide from lead carbonate. On heating gives you lead monoxide and carbon dioxide.
Yes.
So, since your lead monoxide on heating gives red lead, so and the lead hydroxide will give you water and lead monoxide. So you will have carbon dioxide, water and red lead. So the white color will change into scarlet color, and that's an indication that the red lead has formed. So the white lead on heating gives you red lead, carbon dioxide, water. There are 3 alloys of lead. Solder is used for welding purposes.
Yes.
Which is made of tin and lead. Type metal is made of tin, lead and antimony. Type metal is used for type of typewriter or printing machine. So the alphabets of the printing machines are made of type metal. And rose metal is made of tin, lead and bismuth. And these are used in electrical fuse. You have seen that in the electrical fuse there is a wire goes, and if the excess current is drawn, the wire melts and circuit is broken. So you get dark, no light is available, okay? So this is made of rose metal. That the thin wire which passes through the bridge of the electrical switch is made of rose metal.
Aluminium.
Okay, I will do both. First I will do aluminium, then I will do magnesium. Write down fast. Don't wait for me to complete. As soon as I am writing, you also write. Okay. Now why I have given this formula? Because this is the correct formula for the bauxite, not this one. Although for all purposes we will use this formula, but it does not represent the actual formula. Because the number of water molecules, we write 2 water, but it varies from place to place. If you go to Spain, where the Mediterranean Sea is there, the bauxite will have 3 moles of water. But if you go to the tropic region, where the temperature is high, the bauxite will match with 1 water. So the water content in bauxite varies from place to place. And that is why it is given in a general formula AlOX OH3 minus 2x, where x is greater than 0, less than 1. Bauxite ore has 2 major impurities. So the first, I have to purify the bauxite, then I will do the electrolytic reduction to get aluminium. So first process is purification of bauxite. There are 2 impurities, major impurities. One is Fe2O3, another is silica. So in bauxite you have 2 types of major impurities. One Fe2O3, ferric oxide, another silica, silicon dioxide. Where Fe2O3 is a major impurity, Bass process and Hall's process. L2O3 dot 2 water with Fe2O3. When you react with 40% strength of sodium hydroxide at 150 degrees Celsius at a high pressure, you get sodium aluminate, 80 atmospheric pressure. You get sodium aluminate and ferric hydroxide. Sodium aluminate